Hello, my name is Darryl Gove and I work in the Solaris Studio team doing performance analysis. Today I'm joined by Steve Clamage, our C++ project lead and also the chair of the US C++ committee. Thank you for joining me, Steve.
I'm happy to be here.
So we've got a new C++ standard, the 2011 standard. The previous standard was 2003.
That's right.
So can you tell me something about the process of getting from that previous standard to this new one?
So after the 2003 standard, there were a lot of features that people had been thinking about would be interesting to put into the C++ language. At some point you have to decide what we have is good enough to publish, and it had been 5 years since the previous standard. The C++ 2003 standard was basically fixing bugs in the original. There were things that were improperly specified, where specifications conflicted, some things just weren't specified at all.
Okay.
So that took care of those problems. In the meantime, everybody had his own favorite list of features that he'd like to see in the language. So we spent some time working on those. Some of these features were quite elaborate, and in the end, there wasn't time to get them in.
Okay.
Even to the C++ 11 standard. Some things just, it requires a large number of people to agree on a lot of details. Part of the problem of introducing a new feature into the language is how does it interact with existing features? And those are the major problems that have to be solved. It's easy to come up with a bright idea, but making it work with the rest of the language is much harder.
Right, so basically you've got to figure out how to incorporate new features, new concepts into the language without breaking the stuff that's already there.
Yes, and in particular, put it in a way that it can be taught and explained and understood without a lot of surprises.
Right.
So that if you can find feature A works, feature B works, use them together, and something strange happens, that's not good.
So what's gone into the new standard? Is there substantial changes or minor changes?
Yes, there's substantial changes. There are also some small changes
Right.
as well. The new standard, just to look at the document, is approximately twice as long as the 2003 standard. The runtime library, all of the things that make the language easier and more fun to use, is about 3 times the size.
Okay, that's big.
I was trying to think of how to characterize what's new. The problem is, with so many new features, it's hard to pick out just a few to talk about in a short talk. For comparison, Scott Myers, who lectures and teaches and writes books about C++, has a 5-day course explaining what's new.
Right.
I have a 2-hour talk that I give on what's new,
Okay.
and that's only a fraction.
Yeah, so we probably won't get into many details.
Not today,
here.
yes.
Okay, so, but are there any top-level highlights you can give?
There's a couple of major new ideas in C++
Right.
11. One is references to R values, and R value is just a value as opposed to an object.
Right, okay.
This was not previously allowed, but it's a powerful new idea because it enables you to do things like move objects without having to make extra copies.
Yeah.
So this was introduced partly to give efficiency, but it also enables some new ways to program. Another major feature is lambda expressions, which exist in some other modern languages, actually some old languages as well.
Okay.
Lambda can be thought of as an on-the-fly function, where you don't have to go through all the overhead and boilerplate of making a function and being able to call it, and the lambda can carry its own data along with it like a function object in traditional C++.
Right.
So
So-
this enables new styles of programming as well.
For lambda expressions, can you give me a simple example of where you might use a lambda?
Well, let's consider the standard sort function,
Okay.
which takes a comparison function as one of its arguments.
Right.
Well, unless you want to use something that's already built in for comparison, you have to write a special function, give it a name, make sure it doesn't conflict with any other names, and then call that function and then pass that function into the sort function. Using a lambda expression, you can just write the function in place using a special syntax. And you're only using it once in this one context. It doesn't need a name. In fact, it doesn't have a name.
So does that give you any other advantages than just kind of dumping a function into...
Yes, it does. A lambda is, when declared inside a function, can inherit, in a sense, the local variables of that function without them being explicit parameters.
Right.
So this gives what's called in computer science a closure, where this function, since it's passed along to another function, can be called in a context where the context of the calling function is still available, something not possible otherwise.
Does the new standard change my existing code?
That's a very good question. Almost entirely, it's new features, new things you could do that you couldn't do before.
Right.
Essentially, all of standard C++ 03 is still valid C++ 11. The one exception is the keyword auto has been repurposed.
But can I mix 03 and 11 code otherwise?
Let's look at this from two standpoints. One,
Okay.
source code, and the other, object code.
Right.
So for the source code, since C++ 11 is effectively a pure superset, your old code, assuming it was valid C++ 03, should still compile. Now,
Yeah.
in the real, and produce the same result.
Yeah.
In the real world, people come to rely on non-standard features of compilers or bugs in the compiler that allow non-standard code to be accepted. And with any C++ 11 compiler, you might find that some of those things have been tightened up a bit, and maybe your code won't compile. It's not because it's C++ 11, it's because the compiler has gotten more picky.
Right.
This is certainly true for our compiler.
Okay.
Secondly, object code. If I have some old binaries that I built with say, the previous compiler, and now I compile some C++ 11 code, can I link them together?
Yeah.
That will depend on the compiler. In our compiler, the answer is no. You have to recompile the code. The reason is that the ABI, that is to say the way binary code is generated by the compiler, that ABI was not adequate for C++ 11, and we would have to make some changes.
Do you have any features in the language that you think programmers will leap out and say, oh, that's just what I've been waiting for?
Well, let's go back to the first question about how something gets into the standard.
Okay.
First of all, somebody has to feel passionately enough about this feature to walk it through email discussions and face-to-face meetings over a period of sometimes several years and persuade everybody else on the committee that this is a really good idea.
Okay.
That's how it gets into the standard. So this means that this feature is considered by at least some group of people to be important and useful. Okay. So this is pretty much true of everything that's new. So for anybody who reads through a list of new features is going to find several who will say, oh, I'm so glad that's there, I'm going to start using it immediately. Right. But somebody else would have a different set of features that they like.
Okay. So there's tons in there for everyone.
There's tons of stuff in there, something to please everybody.
Brilliant.